Hello, welcome back to the electrolytic cell chain. Today I'm going to be making a nickel chloride using scrap nickel bits, hydrogen peroxide, muriatic acid, also known as hydrochloric acid or HCl for short, and I will just need one beaker of any kind. It doesn't have to be this shape. As always, safety first. We don't want to lose any eyes. Make sure that you do reactions, no matter how minimal the reaction is, either with the hood system or outside in a well-ventilated area. Always remember to wear gloves when handling corrosive substances and metals that may or may not be toxic in their many different states. Let's begin. This is a relatively mild reaction. You will not have to deal with any fumes, so to speak. So first I'm going to carefully add the nickel so that it doesn't break the beaker. Our goal is not to waste money on new beakers. So let me get that put in there. This is the first step required to start a nickel electrolytic cell for use of growing crystals or plating something in nickel. Nickel is a very useful tool in the electroplating industry. It is commonly used to plate underneath gold and other metals because it has a better adhesion. Alright, so now we've got our nickel in our beaker. And we're going to go ahead and add hydrochloric acid. Now, hydrochloric acid is normally clear, but this hydrochloric acid has an additive in it that I am assuming is, of course, not only inert, because a chemical company wants to get in trouble for adding stuff that would ruin things, but it's to prevent people from thinking that it's water, because it comes in a jug that looks like water. So they made it look a little more like pee, just a little less appetizing. So, all right, now we have our hydrochloric acid and our nickel sitting together in the beaker. And what I'm going to do is I'm going to try and oxidize the nickel a little bit faster to get the reaction to start by adding just a tiny amount of hydrogen peroxide. Now what this will do is it'll create gas. Oop, I gotta open it. It'll create a gas of hydrogen, and there'll possibly be a small amount of chlorine gas that also comes off. So I'm going to use just a tiny capful. I don't want to use the whole bottle because that would be explosive. So we'll go ahead and watch this reaction. I'm adding a very, very small amount, a few drops. And as experiments tend to go, I am surprised. I was expecting there to be a bit of a reaction with the hydrogen peroxide. I might have bad hydrogen peroxide. Also, I'm using 3%. Normally when refining metals, you use a higher percentage in that 20-30% range, but as you can see, we're already starting to turn green in the solution. Just a little bit. So this, I could add other volatile chemicals to this, but I don't want to do things with volatile chemicals. I want to keep it at a minimum. A tiny bit of hydrogen or hydrochloric acid that will go into the solution and then stay in the solution and be used over and over and over and over and over and over again without being ever thrown away. I can deal with that. But yeah, I don't want to do anything that is just creating a whole bunch of chemical waste on the planet. We don't need any more of that. But anyways, check back, and in the next couple videos, we will see where this has gone over the next few days. All right, be sure to like and subscribe.